Um, Good morning, colleagues. I'm Busi Manchu, the subject advisor of physical sciences in Thabo Mofokeng. As you all know, we are going to do the memo discussion for physical sciences, paper 2. The reason there was an addendum, I think you all know, it's because fertilizers is no longer examinable for this year. So the paper was set before fertilizers were taken out. So the fertilizer questions had to be replaced. Now, as you all know, in the first question, the fertilizers were in question 1.10. So all the other questions from 1.9 to 1, from 1.1 to 1.9 will remain as they are. And also in the memorandum, they remain as the ones that are given. But 1.10 was replaced as follows. The electrolytic cell illustrated below is used to electroplate a nickel rod with copper. And the diagram was given there. Which one of the following is the correct representation of a suitable electrolyte and the nickel rod that should be used in the above cell to obtain the expected results, which is the electroplating? So the correct answer there is D. So in your memorandum, you have to replace in 1.10, you have to replace that C with a D because the C was for the fertilizer industry question. Now, let us go then to question 2, colleagues. The others remain as they are in question 1. Now, question 2, the letters A to E in the table below represent 5 organic compounds, and those are the organic compounds given from A to E. 2.1, write down the letter that represents each of the following. 2.11, a ketone. So the letter that represents a ketone there should be a C. So C is a ketone. And bear with me, colleagues, remember I want to bring our new teachers on board. So when we mark, colleagues, let us ensure that we put the tick next to the correct answer. So the answer there is C. You just put a tick because it's 1 mark. On the right hand side of the script of the learner, you'll write 1. And then a letter that represents a hydrocarbon for 212 and the letter that represents an alkene for 213. So a hydrocarbon in 212, it's either B or E. So the learner doesn't have to write both. If the learner writes B, it's 1 mark, or if the learner writes E, it's 1 mark. Put 1 tick and then you transfer the mark to the right hand side of the learner script. And then the letter that represents an alkene is E. It's 1 mark, 1 tick, and then you write the mark there on the right hand side as 1. And then 221, write down the IUPAC name of compound A. Now the correct IUPAC name of compound A, it's 2-bromo-4-ethyl-3,3-dimethyl hexane. So it's 2-bromo-4-ethyl-3,3-dibromohexane. Now that is 3 marks. How do we mark the 3 marks? If you see a hexane in the learner's answer, it doesn't matter where it is. When there is hexane, it's 1 mark. And then for the second mark, you look for bromo, you look for ethyl, you look for dimethyl. All 3 of these, if they are there, the learner will get the second mark. Remember, you only look for bromo, ethyl, and dimethyl. You don't consider the numbers next to those bromo, ethyl, and dimethyl. We have seen in June, colleagues, some of you have penalized learners. If this bromo does not go with a 2, say for instance, the learner says 3 bromo, you now penalize the learner. Remember, these numbers and the commas and the hyphens only come in the 3rd bullet. So ensure that you mark according to the bullets. So now in the 3rd bullet, you look for substituents correctly numbered, in alphabetical order, hyphens and commas correctly used. In other words, everything must be correct for you to give the 3rd mark. So for the 3rd mark, it's hexane. It doesn't matter where it is. 2nd mark, it's bromo. it's ethyl and dimethyl, and all three of them must be there. If one of them is missing, no mark. All three of them must be there. And remember, in dimethyl, it must be dimethyl. If the learner says methyl, it means it's no longer correct. That is all three of them for the second mark. And then for the third mark, it means everything must be correct. This means if it happens that either the learner loses the first mark or the second mark, automatically that learner will lose the third mark, because for you to give the third mark, everything must be correct, including the one that you have already marked. Fine. And then write down the structural formula of compound D in 2.2.2. The structural formula of compound D is as follows. The way you mark, if there are 6 carbons in the longest chain, in other words, you see 6 carbons forming a chain, then you will give a mark. And then the hydroxyl group must be on the 3rd carbon, then you'll give your second mark. And then if it happens that one or more of the hydrogen atoms is omitted, then you'll penalize 1 mark. And then if a condensed or a semi-structural formula is given, you also deduct a mark. Remember, a condensed structural formula, colleagues, will be, for example, CH3, CH2, CH2, CH, maybe with an OH, and then a CH and a CH3. Whether the OH is there as I've written or is written as a branch, as long as these are the others are condensed, then it's a condensed structural formula. A semi-structural formula, one of them, say for instance, you can have a CH3, and then you'll have the others in the form of a structural formula. And then we say that is a semi-structural formula because one of them or more of them are condensed. Some of them will write it as like this. So that is a semi-structural formula. If you see something like this, it means this learner will get the first mark for the 6 carbon atoms in this in the chain, and then you'll still give a mark for the hydroxyl, but you'll take one of the marks because it is a semi-structural formula. Therefore, this learner will get 1 out of 2. The next question, write down the IUPAC name of the straight chain functional isomer of compound C. It is the IUPAC name. So the correct answer there is pentanal. Now we have seen, for that, the marking criteria is as follows. For the correct functional group, which is the AL, you'll give 1 mark, and then if the whole name is correct, including the AL that you've given, in other words, pentanal, therefore you'll give the second mark. Let us make an example. Here's a learner. The learner writes butanal. Another learner writes butanol. Another writes pentanol. So the criteria says you give a mark for the functional group. It's 1 mark for the AL, but because it's supposed to be butanal, therefore the learner will lose the second mark. This learner will get 1 out of 2. Unfortunately, this one already, it's supposed to be an AL. So it means this learner will get 0 out of 2. Pentanol, it's supposed to be an AL. And then the rest must be correct. So an AL is incorrect, it means this learner will get 0 out of 2. The reason I'm doing this is because this criteria does not say 1 for AL and then 1 for pentan. Pentan, yes. It's 1 for AL and 1 for everything. So if it's not an aldehyde, it means it's 0 out of 2. Then there's this other new trend that we see now. This learner will write the number of the functional group. This learner will write pentan 1 al. Remember, the functional group of an aldehyde is always on carbon 1, so they don't need to write that 1, the number where it is. And actually, if they write that number, it isn't correct. So colleagues, you would give 1 mark for al, you would give 1 mark for everything is correct, but because of the 1, you have to penalize. It means this learner will get 1 out of 2. So anything, as long as you see the 1 on the al, you must know that there's no mark there. And please, colleagues, we are doing this because we want you to go back to your learners and show them where they lose marks. So please tell them that if they write that 1 in an aldehyde, they lose a mark because always the functional group in an aldehyde is on carbon 1. So they don't write that 1. And then the next question, 2.3. In 2.3, compound B is a straight chain compound that undergoes the following exothermic reaction. And the reaction is given there. 231, besides being exothermic, what type of reaction is represented above? So the reaction that is represented there is oxidation for 1 mark or combustion for 1 mark. One of them. It's 1 mark. 2.3.2, determine the molecular formula of compound B for 2 marks. So the molecular formula of compound D is C8H18. And please, colleagues, take note that it is written 2 or 0. So if any of these is incorrect, it's 0. Learner cannot say C8H16, you say C8 is 1 mark and then H16 is incorrect. If anything is incorrect, it's 0. It has to be C8H18 for 2 marks. And sometimes colleagues will miss the 2 marks. So in your memo, you can just encircle the 2 ticks or you highlight the 2 ticks so that you don't miss it. You have to ensure that the learner gets 2 marks. You don't give 1. And that was 2.3.2. And then 2.3.3, calculate the total volume of gas formed in the container when 50 cubic centimeters of CXHY reacts completely with oxygen. And that is for 3 marks. So for that 3 marks, the marking criteria, the first mark is for the use of the volume ratio, which is the volume of carbon dioxide to the volume of B, as well as the volume of water to the volume of B. The volume of carbon dioxide to the volume of B is 2 to 1, and the volume of water to the volume of B is 9 to 1. For both of those, it's 1 mark. And then for the second mark, the addition of the volume of carbon dioxide to the volume of water. In fact, it is not water, it is steam. Remember, it is the volume of gas. So that water is in the form of a gas. So it's volume of carbon dioxide and the volume of steam. The addition of those volumes is the second mark. And then the final answer there, it's 850 cubic centimeters. So in the first option, this learner uses the ratio. Volume of carbon dioxide is 8 multiplied by the volume of B. So that is volume, the ratio of the volume, the ratio that they are supposed to use there. To calculate the volume of carbon dioxide, they multiplied by 8 multiplied by the volume of B. And the volume of B was given as 50. So they get it as 400 cubic centimeters. Now, also to get the volume of steam, it is 18 divided by 2. The volume of water will be 9 multiplied by the volume of B, which is 50. That will give us 450. That is the first mark for the use of the ratio. And then for the second mark, they have to add these volumes, volume of carbon dioxide and volume of steam. That is the second mark. And then for the last mark, it's 850 cubic centimeters. Or they can use the moles. 2 moles of CXHY will form 16 plus 18, which is 34 moles of gas. And then 50 moles of CXHY will form 25 multiplied by the 34 total moles of gas, and then the total moles of gas there will be 850 cubic centimeters. any one of those. The most important thing, you have to check the use of the mole ratio, and then you have to check the addition of the volumes, and then the final answer is 850. They might not write it in the form of option 1 and option 2, but just use the marking criteria so that it guides you on how to answer, on how to mark 2.3.3. Now let us go to question 3, colleagues. That was all about question 2. Question 3. Compounds A, B, and C are used to investigate a factor which influences the boiling points of organic compounds. The results of the investigation are given in the table below. That the table is given there. 3.1. Is this a fair investigation? Choose from yes or no. Now 3.1, the correct answer there is no. And you'll give 1 mark, and then you'll give you'll write the mark on the right hand side. And then 3.2, give a reason for the answer to question 3.1. And colleagues, you can see there's a negative there. The negative that is there means you mark negatively. It's negative marking. It means if the answer to 3.1 is incorrect, automatically the answer to 3.2 is incorrect. You don't even have to read through 3.2. If 3.1 is incorrect, automatically you put a cross on 3.2, because it means the learner cannot motivate a wrong answer correctly. If the answer is wrong, you don't even look at the reason. Now the reason is there is more than one independent variable for 1 mark. Or the learner can say the position of functional groups and branching or chain length differ. That shows that there are 2 independent variables. Or the learner can say compound A and B are positional isomers and compound B and C are chain isomers. It means there are 2 independent variables. And then let us go to question 3.3. Question 3.3, fully explain the difference in boiling points of compound B and C. Now the learner can either answer according to B or according to C, or the combination of B and C. B there, which is butanol, the learner can say B is less branched, or B is less compact, or B is less spherical, or has a longer chain length, or has a larger surface area. That is for the first mark. For the second mark, according to intermolecular forces, the learner can say B has stronger intermolecular forces, or has more intermolecular forces, or has stronger van der Waals forces, stronger London forces, or dispersion forces. And then more energy will be needed to overcome the intermolecular forces. Or the learner can answer according to C, saying C is more branched, or more compact, or more spherical, or has a smaller surface area. That is the first mark. For the second mark, C has weaker intermolecular forces, therefore less energy will be needed to overcome the intermolecular forces. Or the learner can answer according to the combination of the 2. For example, a learner can say from B to C, the chain length decreases. Therefore, the strength of the intermolecular forces becomes weaker. Therefore, less energy is needed to overcome the intermolecular forces. Or the learner can say from C to B, the chain length increases. Therefore, the intermolecular forces become stronger. Therefore, more energy is needed to overcome the intermolecular forces. Just ensure that you read carefully through what the learner is saying and compare to the memo. And then 3.4, colleagues, define the term positional isomer. for 2 marks. A positional isomer. Positional isomers, remember isomers, there must be at least 2 of them. Positional isomers are compounds with the same molecular formula but different positions of the side chains, or different positions of the substituents, or different positions of the functional groups on the parent chain. And colleagues, let us ensure that we take note of the underlined words. All the underlined words must be there for you to give the 2 marks. And then it is said that if one of the underlined key phrases in the correct context is omitted, then you deduct 1 mark. So if any of the underlined words are missing, you'll have to deduct a mark. So it's actually 2 or 0, but if any of these is missing, therefore it's 1 out of 2. We don't, if you see the ticks at the end, it means it's 2 or 0. So we don't mark partially. It's not a part marking, but it's 2 or 0. And if any of these is missing, you deduct a mark. That was 3.4. And then 3.5. Compounds A, B, and C. From compounds A, B, and C, choose the letter or letters that represent each of the following. 351, positional isomers for 1 mark. And then 352, a tertiary alcohol. And give a reason why you say it's a tertiary alcohol for 2 marks. Therefore, 3.5.1, the positional isomers, they are A and B. And for both A and B, it's 1 mark. In other words, if any one of them is missing or any one of them is incorrect, it's 0, colleagues. For that A and B, you give 1 mark. And then the tertiary alcohol, it's C for 1 mark. And then the reason why you say it's C, it's because the carbon bonded to the functional group, or the carbon bonded to the OH group or the hydroxyl group is bonded to 3 carbon atoms. And as you can see, there is no negative marking there. It means even if the learner does not say it's C, but motivates it correctly, you can still give the mark of the reason. Or the learner can say for the reason the functional group or the OH group or the hydroxyl group is bonded to a tertiary carbon atom. That is 2 marks. And then 3.6, the graph below represents the relationship between vapor pressure and the temperature for compound A, which is butane 1-O. 361, write down the value of X. As you can see there, actually learners are supposed to use their definition to know what actually the boiling point is. So the value of X there, as you can see from the graph, X is actually a vapor pressure. So X is 101.3 kilopascals, or X is 1,013 times 10 to the power 5 pascals, or X is 1 atmosphere, or X is 760 millimeter mercury. Now remember, because X was already given in the diagram, and the units of X are given in the diagram. So because the units are already given, even if the learner just says 1 or 1.3 without giving the units, only for kilopascals, you will give a mark for 101.3. But for the rest, the learners must give the units. And then 3.6.2, redraw the graph above in the answer book, and then on the same set of axes, sketch the curve that will be obtained for compound C. Clearly label the curves A and C. Indicate the relevant boiling point of compound C on the graph. So, graph A was already given, the learner just had to redraw it, and then graph C must be drawn, which is above graph A. So let us check the marking criteria. For the first mark, curve C must be above curve A. If curve C is above curve A, you give a mark. And then the value, which is 82 degrees Celsius, which is the boiling point of C, must be indicated where the vapor pressure is, which is X. In other words, that 82 must correspond to that X. Then if that one is there, it's the second mark. But take note, if the curves start at the same point, you'll deduct 1 mark from the marks you've already given. In other words, you have given the first mark for the C being above, you've given the second mark for the 82. But if these curves start from the same point, then you have to penalize 1 mark. And then if the graph C is a straight line, you have to penalize again 1 mark. So please, colleagues, let us mark according to the marking criteria. Let us now continue to question 4. The flow diagram below shows various organic reactions using propane as starting reactant. R, T, and U represent different organic compounds. Compound T is a carboxylic acid, and compound U is a functional isomer of pentanoic acid. Then you can see the flow diagram that is given. Write down the name of the type of reaction represented by 411 reaction 1 and 412 by reaction 2. So the name of the type of reaction represented by reaction 1 there is substitution reaction for 1 mark, or halogenation or bromination. And the name of the type of reaction represented by reaction 2 is substitution reaction or hydrolysis. Any one of those is 1 mark. And colleagues, don't forget, you put a tick and then you put the marks on the right hand side. 413, consider reactions 1 and 2. Write down the IUPAC name of compound R. The IUPAC name of compound R is 1-bromopropane. If the learner just writes bromopropane, then you'll give 1 out of 2. If the learner writes 2-bromopropane, you'll give the learner 1 out of 2. So we can safely say for bromopropane, it's 1 mark. And then for the second mark, there must be the 1 and the hyphen that you see that is connected to the bromopropane. Therefore, you'll give the second mark. In other words, if the 1 hyphen is not there, but the bromopropane is there, it's 1 out of 2. 414, write down the name or formula of the reaction 3 takes place in the presence of a catalyst and heat. 414, write down the name or formula of the catalyst that is used. The name of the catalyst used is sulfuric acid, or the formula is H2SO4. The word concentrated need not be there. Write down the IUPAC name of compound T. The IUPAC name of compound T is ethanoic acid. And when you see that the whole ethanoic acid is underlined, it means for those 2 marks, ethanoic acid must be written as it is. And as you see, it's 2 marks. It doesn't say ethanoic 1 mark, acid 1 mark. It's 2 or 0. So if a learner, for example, just writes ethanoic without the word acid, it's 0 out of 2, unfortunately, according to the underlined word. If everything is underlined, it means everything must be there. Anything missing, 0. 416, write down the structural formula of compound U. For that, the first mark is for the correct functional group. Remember, colleagues, when you say correct functional group, the bonds must be correct as well. So it's the carbon that is connected to the O. That carbon must have 3 bonds on the left-hand side and the fourth bond that is connected to O, and then a C double bond O with the correct bond that goes to the other carbon. For all of that, it's 1 mark as a functional group, and if the functional group is correct, then you check the whole structure. Then if the whole structure is correct, it's 2 marks. Remember, if the functional group is incorrect, therefore it's already 0 out of 2. Always when you mark your structures, whether it's the structural formula, the condensed structural formula, when you see the functional group is incorrect, automatically the whole structure is incorrect. It's 0 out of 2. And then, if one or more of the hydrogens is omitted, you'll penalize 1 mark. Excuse me. And then, if the condensed or semi-structural formula is given, you'll penalize a mark as well. And then that was 416. And then, let us now continue. Question 4.2. A laboratory technician wants to prepare but-2-ene using but-1-ene as a starting reagent as shown below. The following chemicals are available in the laboratory: concentrated sulfuric acid, water, and concentrated sodium hydroxide. Select the chemicals required to design this preparation from the list above. For each step of the preparation, write down the balanced equation using structural formulae for all the organic compounds. Indicate the chemicals needed in each step. So that is 6 marks. The learner has to start with the initial reactant, which is but-1-ene. So the first reactant there is but-1-ene, and then reacts it with water in the presence of sulfuric acid. And then the product there will be butan-2-ol. The OH is on carbon 2. Now, from butan-2-ol, the learner heats butan-2-ol in the presence of sulfuric acid again, and then the learner will get but-2-ene plus the release of water. Now, how do we mark these? For the product, the product in the first reaction, it must be an alcohol. So if you see it's an alcohol, in other words, for the functional group, there must be a carbon with an OH and the correct number of bonds. For the functional group, it's 1 mark, and then if the whole structure is correct, you'll give the 2nd mark. And then in the first reaction, you'll have to check that in the first reaction, you have but-1-ene as a reactant. So if you have but-1-ene as a reactant and it reacts with water in the presence of sulfuric acid, therefore you'll give a mark of water and sulfuric acid. So you'll only give a mark of water and sulfuric acid if the reactant is but-1-ene. And then in the second reaction, the reactant must be butan-2-ol. Then in the presence of sulfuric acid, in the second reaction, you'll only give the mark of sulfuric acid if the reactant is butan-2-ol. And then the product there, it must be but-2-ene with the correct number of bonds, the double bond in the correct position, everything must be correct to give the mark of but-2-ene, and then the mark of water as a product. Now let us check the criteria or the notes. If a condensed or semi-structural formula is given, remember a condensed or semi-structural formula must be for organic compounds. So for any of the organic compounds, if a condensed or semi-structural formula is given, you'll deduct 1 mark from the marks that are already given. If a molecular formula is used, no mark for the organic reactant or the organic product. No mark for any of the organic structure. It means the 3 marks that you can give will only be for inorganic reactants. or the inorganic products. In other words, it will only be for water and sulfuric acid. That is the first mark. The sulfuric acid in the second reaction and the water in the third reaction. That's the only mark that you'll be given, or the only marks that you will be given for the molecular formula. Hence, it is maximum of 3 out of 6. And then marking rule 6.3.10 applies. Remember, colleagues, that marking rule says for you to be able to mark these products, the arrow must be there on the left-hand side, or at least there must be a dash showing that it is a product, or there must be an equal sign that shows that it is a product. So for you to mark this, there must be something here that indicates that this is a product. The same thing applies here. For you to be able to mark these, there must be an arrow or an equal sign or a dash at least that indicates that this is a product. That's marking rule 6.3.10. And then for any additional reactants or products, it doesn't matter how many additional reactants and how many additional products there are, you'll only penalize once. It's 1 mark. And then if an arrow in an equation is omitted, you'll penalize 1 mark. In other words, for that learner, instead of using an arrow that uses an equal sign, or instead of using the arrow, the learner uses a dash, you'll penalize 1 mark here, because it must definitely be an arrow. I hope that is clear, colleagues. And colleagues, I wanted to, for our new teachers, they must know that, as I was saying, as you mark here, you put a tick, you put the mark on the right hand side. Then at the end, you just add these marks on the right hand side of all the question, in other words, of all question 4. So for example, say for instance, this learner will get 2, 4, 5, 6, 7, 8, 9. This learner, you get 9, therefore you'll put a 9 next to question 4, which is the total of all the marks in question 4. In each question you do like that. So remember, as you put a tick, you put the marks on the right hand side. At the end, you add the marks on the right hand side, and then you put the total next to the question number. And then let us go to question 5. In question 5, study the Maxwell-Boltzmann distribution curve for a certain reaction below. The curve is given there. P and Q are labels on the axis. What quantity is represented by 511P and by 512Q? So in 5.1.1, P is kinetic energy. Remember, P is on the x-axis, so P is kinetic energy. And then 5.1.2, Q is number of particles or number of molecules. That is Q. And then 5.2, line R represents the minimum energy required for the reaction to take place. 5.2.1, write down the term for the underlined phrase, and that is the activation energy. 1 mark, and then you put the mark on the right hand side. 5.2.2, how will the shaded area on the graph be affected when a catalyst is added? Choose from increase, decrease, or remain the same. Now in 5.2.2, the shaded area will increase. And then 5.3, use the collision theory to explain how a catalyst influences the rate of reaction. That is 4 marks. Now the marks that are expected there. The first one, a catalyst provides an alternative path of lower activation energy. But the underlined words there are lower activation energy. So some of the learners would just say a catalyst lowers an activation energy. As long as you see lower activation energy, it's a mark. But just teach them, colleagues, the correct way of saying it. It provides an alternative path of lower activation energy. That's the first mark. And then for the second mark, more molecules will have sufficient kinetic energy. Remember, they can say more molecules will have the kinetic energy that is greater or equal to the activation energy. It's fine. That is the second mark. And then the third mark, more effective collisions per unit time. More effective collisions per unit time. And if any of these words is missing, colleagues, no mark. For example, learners tend to say effective collisions per unit time. There's no mark there because effective collisions were there. But because of the addition of the catalyst, there is more of them now. So the word more is important. More effective collisions. And if the learner just says more effective collisions without the words per unit time, there's no mark there as well. So all these words must be there for you to give the third mark. Or frequency of effective collisions increases. All those words as well. That is the third mark, and therefore the rate of reaction increases. That's the fourth mark. And that was 5.3. Now let us move to 5.4. In 5.4, the reaction between powdered calcium carbonate and excess hydrochloric acid is used to investigate the reaction rate at 25 degrees Celsius. The balance equation for the reaction is given there. And then several experiments are conducted using the same mass of impure calcium carbonate and different initial concentrations of dilute hydrochloric acid. The graph below represents the results obtained. Assume that the impurities do not react, and the graph, colleagues, is given there. And then 5.4.1, for this investigation, write down a controlled variable, and 5.4.2, for this investigation, write down a conclusion. So in 5.4.1, the controlled variable, it is the temperature, or it is the surface area, or it is the amount of calcium carbonate, or it is the mass of calcium carbonate. Any one of those is 1 mark. And then 5.4.2, write down the conclusion for 2 marks. So remember, colleagues, in the conclusion, the learner must identify the dependent and the independent variable correctly. In other words, if the words reaction rate and concentration are there in the learner's statement, at least the learner will get 1 mark. And then for the second mark, the learner must now write a correct relationship between the reaction rate and the concentration. For example, rate of reaction rate is directly proportional to concentration. For the first mark, reaction rate and concentration is there, and because the relationship is correct, saying they are directly proportional, then the learner will get 2 marks. Or the learner can say, if the learner says reaction rate increases with an increase in concentration, you'll just give 1 mark for the variables. The learner must relate how it increases. It increases proportionally, directly proportionally so. So if the learner just says reaction rate increases with an increase in concentration, it's only 1 mark for the variables, because the graph, the learners were given the graph, they have to interpret the graph correctly, showing that if the graph gives a straight line, it means these 2 variables are directly proportional. So they can't just say they increase. They must say they increase, forming a straight line, directly proportionally so. So that is 2 marks. And then the calcium carbonate in 6 grams of impure sample reacts completely with 0.03 moles per cubic decimeters of hydrochloric acid in 26 minutes. The calcium carbonate in 6 grams of impure sample reacts completely with 0.03 moles per cubic decimeter hydrochloric acid in 26 minutes. 5.4.3, use the information in the graph to calculate the percentage purity of the calcium carbonate. Assume that the molar gas volume at 25 degrees Celsius is 24,000 cubic centimeters. And that is for 6 marks. Now for the first mark, substitute the volume of 50 cubic centimeters, substitute the rate as 50 cubic centimeters per minute and substitute 26 minutes. So for both of these, the 50 and the 26, for both of them, substituting them in the formula, rate equals delta V over delta T. It's 1 Mach. And then substituting the volume of 1,300 cubic centimeters or 1.3 cubic decimeters, or substituting 24 cubic centimeters per mole or 24 cubic decimeters per mole in N is equal to V over Vm. Any of these volumes, their substitution is 1 Mach. And then the use of ratio of carbon dioxide to calcium carbonate is 1:1, it's 3rd Mach. And then the substituting 100 grams per mole, which is the molar mass of calcium carbonate, in N is equal to mass over molar mass, it's a Mach. And then calculation of percentage purity, taking the mass of calcium carbonate, dividing by the mass of the sample, multiplying by 100. And you'll see also the learners can take the number of moles of calcium carbonate and the number of moles of the sample multiplied by 100. They'll give you the same Mach. So they can either use the masses or the moles. But if they use the masses, both must be masses. If they use the mole, both must be moles. And then the final answer is 90.33. You accept any answer which is between 83.33 to 90.33. Remember, colleagues, the reason why the answers can differ, it's because some of the learners round off during their calculations. So please also ensure that every time when you go back to your learners, you encourage them not to round off whilst they are busy doing their calculation. They can round off to 2 decimal places at the end, but within a calculation, at least they can give as much as possible of the units after or the numbers after the comma, which is the decimal places. Now for option 1, remember the first Mach is for substituting 50 and 26 in the rate equation. So in the rate equation, this 50 and 26, both of them, it's 1 Mach. Substituting them correctly, it's 1 Mach, and then they get the volume. Then they substitute that volume and divide by the molar volume, either for 1,300 or for 24,000 or for 1.3 or for 24. Any of these volumes, it's 1 Mach. And then for the 3rd Mach, the use of the mole ratio, whatever the moles that they got from the calculation of carbon dioxide, if they equate them and say it's the same moles for calcium carbonate, meaning the ratio is 1:1, you'll give 1 Mach. So even if whatever the learner has calculated is not 0,0542, say for instance the learner says it's 0,1, but now, which is the moles of carbon dioxide, but now the learner says the moles of calcium carbonate is also 0,1, it means the learner is using the ratio, so you'll give the Mach for the use of the ratio. And then the learner takes all those moles and multiply them by 100. You'll give the Mach of the multiplied by 100, which is the molar mass. And then the learner now takes this mass that has calculated and divide by the initial mass that was given in the question paper, multiplying it by 100. That is the 5th Mach. Therefore, the final Mach will be 90.33. So any mistake that the learner has made here, it means the final answer will be incorrect. Therefore, the learner will lose the final answer. But any of these, if they are substituted correctly, you'll still give the marks, colleagues. If the learner does not use option 1, then let us check option 2. The learner says the rate is 50 divided by 24,000. So you'll give the Mach of the volume, the 2nd Mach there in our criteria of using 24,000. So for 24,000, the learner will get a Mach. And then the learner calculates the rate. Then takes the rate and multiplies by 26. So for the 50 that was used initially and the 26 that the learner now multiplies with, that 50 and the 26, that is in the first bullet. That is the mark that you'll give now. And then for use of the mole ratio of calcium carbonate to carbon dioxide, which is 1:1, you'll give the third mark. For the multiplication by the molar mass of 100, you'll give the fourth mark. For now using the mass that he has calculated now, divided by the initial mass multiplied by 100, that is the fifth mark. And then the final answer is 90.33. But the learner can use the moles. So the learner can calculate the moles of calcium carbonate, which is mass over molar mass 6, which is the original mass that was given, divided by 100. So you'll give the molar mass, that fourth mark here, the one of substituting 100 grams per mole in this formula. So you'll start with it here. Substitution of 100 in this formula, it's 1 mark. And then the learner uses the rate formula and substitutes 50 and 26. That is the mark in the first bullet. And then using the volume that the learner has calculated, divide by 24,000, which is the molar volume, either the mark of 1,300 or 24,000, it's a mark. And then the use of the mole ratio there, which is 0.0542, it's a mark. Then the learner does not convert back to masses. The learner now works with moles. 0.0542 divided by the moles there that the learner used initially, which is 0.06 multiplied by 100. That is the fifth mark, and the answer there is still 90.33. The learner can use, like did in option 2, the molar mass mark of 100 is 1 mark, and then the volume mass of 24,000, that is the second mark, and then the use of 50 and 26, that is the third mark, and then the mole ratio mark 1:1, that's the fourth mark, and then using those moles divided by initial moles multiplied by 100, it's a fifth mark, and the final answer there, it's 90.33. Just remember, because of the rounding off, the answer can be anything between 83.33 to 90.33. Anything that is outside this range, you may not give the mark for the final answer. That was 5.5. 5.4.3. It's 5.4.3 in the question paper. It means actually this is 5.4.3 in your memorandum. 5.4.3. And that is the total of 6 marks in 5.4.3. So that is all for question 5. Colleagues, I suggest we take a 10-minute break, a 10-minute comfort break, and let us come back. It's almost 10. Let us come back at 10:10 so that we continue with the rest of the question paper. And if you have any questions, just forward them to your subject advisors, and then we'll try to have a look at those questions before we wrap up. Thank you very much, colleagues. Let us meet at 10:10. Thank you. Welcome back, colleagues. I hope you are all back and you are able to connect so that we can continue. We are supposed to start with question 6, but now that we have a question, let me just start with a question. In question 4.1.3, colleagues, the answer there, remember, was 1 bromopropane. And I said to you, let us give 1 mark for bromopropane, and then the second mark, the learner can only obtain if there is 1 hyphen that is connected to the bromopropane. Remember, it must be at the beginning. Now, the learner says 1,2 bromopropane. Therefore, it means you will only give 1 mark for the bromopropane, but because of this, the learner will lose the second mark. Therefore, it will be 1 out of 2. The question was, do we give 1 mark or 0? So you'll give 1 mark for bromopropane, and because of this first part that is incorrect, it's supposed to be 1 hyphen. Therefore, the learner will get 1 out of 2. I hope that is clear. Let us now go back to question 6. In question 6, there we have a statement: steam, which is water that is in the gaseous phase, reacts with hot carbon dioxide. With hot carbon at 1000 degrees Celsius according to the following balanced equation. And the balanced equation is given there. Initially, 36 grams of steam and a certain amount of carbon were placed in a 2 cubic decimeter sealed container and allowed to react. And then at equilibrium, it was found that the amount of carbon changed by 0.25. And the word changed by, not changed to, is a very important for our learners to interpret. And colleagues, please also go back to them and try at least to explain the difference between it changed by. It means the amount that reacted of carbon is 0.225, not the amount that is left in the container, but the amount that has reacted. And this is also important for the rate question, where they are supposed to calculate the reaction rate. They must remember that they use the amount that has reacted, not the amount that is left. If they have the amount that is left, they have to subtract it from the amount that they started with so that they get the amount that has reacted. So it is important for them to be able to interpret these kinds of questions. And the only way they'll be able to interpret them is if you give them those kinds of questions. 6.1, define the term dynamic equilibrium for 2 marks. Now, for us to give marks there, the answer is, it is the stage in a chemical equilibrium when the rate of forward reaction equals the rate of reverse reaction. And the underlined words are the rate of forward reaction equals the rate of reverse reaction. That is 2 or 0. If the words rate are not there, it means it's 0. Or anything that is missing there is 0. And colleagues, please let us ensure that the learners understand the words reverse and forward, because some of them, they would say the rate of the forward reaction equals the rate of the reversible reaction. Let us ensure that we explain to them from reactants to products is the forward reaction, from products to reactants is the reverse reaction. And if the reaction has both the forward and reverse reaction, we say it is reversible. So reversible reaction is not only from forward to from products to reactants. Let us just emphasize that, because some will say the rate of forward reaction equals the rate of reversible reaction, which is incorrect. Or they can say it is a state in a chemical reaction when the concentrations of reactants and the concentration of products remain constant. That is 2 or 0 as well. Let us take note of the underlined words. 6.2. Calculate the equilibrium constant, which is Kc, for the reaction at 1000 degrees Celsius. That is 8 marks. So if the learner uses the number of moles, as most of them do, the marking criteria when they use the number of moles, the first mark, the substitution of 18, which is the molar mass of water, of steam, in the formula, N is equal to mass over molar mass. Remember, if it was water, which is a liquid, we would not use it in our Kc because the concentration of water remains constant. It is a pure liquid. But if it is in the form of steam, we do use it. And then the second mark, change in carbon dioxide equals the change in carbon, which is 0.3. 225 moles. That is mark number 2. And then mark number 3, the use of mole ratio there, moles of carbon to the moles of steam to the moles of carbon dioxide. It is 2 to 1 to 2. That is the third mark. And then for the fourth mark, we have a look at all of these. To calculate the moles of steam at equilibrium, it must be initial moles minus a change in moles. And then to calculate the moles of hydrogen at equilibrium and the moles of carbon dioxide at equilibrium, it is the initial moles plus the change in moles of hydrogen. And for carbon dioxide, it is the initial moles plus the change in moles of carbon dioxide. All of those three calculations, it is 1 mark. And then the next mark, if you divide all of the equilibrium moles of water, of steam, of carbon, and of carbon dioxide, divide all those equilibrium moles by 2, you will get a equilibrium moles. That is the next mark of the divide by 2. And then the next mark, the correct Kc expression. And colleagues, let us emphasize this Kc expression, these formulae must be in square brackets. If they are in round brackets, do not give a mark. They must be in square brackets. And then the next one, the substitutions of the Kc, of the equilibrium concentration in the correct Kc expression. And then the final mark there is 0,00948. And the range there is 0,0948 to 0,01. Now let us have a look at what the learners have written. If the learner initially writes 36 grams divided by 18, therefore the answer there is 2. So you will give the mark of the divide by 18 or the mark of the molar mass of steam there. That is 1 mark. If the learner does not show this, but you see a 2 here, therefore you will give that first mark there, because the learner can only obtain the 2 when he divides the mass by 18. So that will be the first mark. It's either you give it there as the molar mass of 18, or if you see a 2 there, you'll give a mark showing that the learner has divided by the molar mass of 18. And then for the second mark, the learner was told that the change in moles of carbon is 0,225. And the learner now uses the mole ratio and gets the change in moles of carbon dioxide as 0,225. So if you see 0,225 in change in moles of carbon dioxide, you'll give the second mark. And then the learner for the third mark uses the mole ratio now. Says, okay, the mole ratio of steam to carbon dioxide is 2 to 1, and the mole ratio of hydrogen to steam is 2 to 1. Therefore, the correct mole ratio here, you'll give the third mark. And then for the fourth mark, the learner must say for steam, initial minus change in moles gets this value, a certain value, and 0 plus change in moles of hydrogen gives the certain value. 0 plus the change in moles of carbon dioxide gives that value. All of those calculations, the learner will get a mark. And then the next mark, the learner takes all these equilibrium moles and divide them by 2. If all of them are divided by 2 to give this, you'll give the third mark. In other words, if any one of them was not divided by 2, you'll not give this mark here. And then the next one, the correct Kc expression with hydrogen, concentration of hydrogen and concentration of carbon dioxide as numerator, and concentration of hydrogen squared. And then concentration of water as a denominator, and that concentration of water must be squared. Remember, I'm saying concentration because I can see the square brackets, meaning if the learner does not use the square brackets, it's not the concentration, therefore you may not give the mark. For all of that, it's a mark. And some of our learners, colleagues, tend to forget these subscripts. The learner will just say concentration of H if it's like that, concentration of H squared with concentration of CO squared, then, I mean concentration of CO even without a squared, you may not give the mark for the KC expressions because these formulae are incorrect. But, okay, and then the next one, whatever the learner has calculated there as the concentration of steam, water, and carbon dioxide, and substitute them correctly in the correct KC expression. Therefore, you'll give a mark. And the final answer there must be 0,00948, or any range between 0,00948 to 0,01. Now, if it happens that everything is correct, but this learner did not write the KC expression, but you can see that there are KC substitutions that are correct from the table, but the learner did not write the KC expression, then the learner will just lose the mark for the KC expression, but you still mark further to give the substitutions, the correct substitutions, and the final answer there. And then, if the KC expression is wrong, for example, the learner has taken water and put it as a numerator and taken the hydrogen and carbon dioxide concentrations and put it as a denominator, we say that KC expression is incorrect. Therefore, you will not mark any further. The learner uses the KC expression mark, the learner uses the substitution mark, and the learner uses the final mark. Hence, the maximum can be 5 out of 8, depending on what the learner has gotten on the table. But say, for instance, the mistake that the learner has made is just not writing the subscripts, but these are correct. Concentration of hydrogen of H squared, concentration of CO, and then divide by concentration of H2O squared. The learner, the only mistake is that the learner did not write the subscripts, but these are already as numerator and the steam is as denominator and squared correctly. We don't say that is an incorrect KC expression. That is just a writing error. So in other words, the learner will lose the mark for the KC expression, but you will still mark further. We say the KC is wrong if, for example, the learner has swapped the numerator and the denominator, or if the learner has omitted the power, the power to the power 2. In other words, the learner did not square what he was supposed to square. Therefore, that KC expression is incorrect. It means the learner will get a maximum of 5 out of 8. Instead of using the moles, the learner can use the concentrations. So if the learner uses the concentrations, then we mark as follows. We still give a mark for the divide by 18, which is the molar mass in the formula. N is equal to mass over molar mass. That is the first mark. And then the second mark, dividing the initial moles, which is the 2 moles, dividing the initial moles by 2, which is the volume. Remember, this is the concentration option, so the learner must move from moles to concentration. Therefore, the learner will use the 2 and divide it by the 2, which is the volume, to get the concentration. And then divide the initial moles of steam as well as the change in concentration, the change in moles of carbon dioxide by 2. In other words, when you see this 1, you would know that the learner has divided the initial moles of steam by 2. And when you see this 0,1125, you'll know that the learner has divided the change in concentration, the change in moles, which is the 0,225, change in moles of carbon dioxide by 2. Therefore, when you see these 2 numbers, you'll know that you'll give the mark in the second bullet. And then in the third bullet, the learner must say change in moles of carbon dioxide equals the change in moles of carbon. But because we are dealing with concentration, the learner will take that change in moles of carbon dioxide, which is 0,225, divided by 2 to get the 0,1125. So if you see this 0,1125, that is the mark of the third bullet. We can see that it looks like we give this mark twice, because when you see these 2, you know that it is the second bullet, and then when you see this 0,1125, it is the third bullet. And then after getting this 0,1125, therefore the learner uses the mole ratio to get these other 2. that is the fourth mark. Then the fifth mark, the learner must subtract for the reactants 1 minus the change in concentration to get the equilibrium concentration of steam, and then the addition of initial moles to the change in initial concentration to the change in concentration of water and of hydrogen and carbon dioxide. That addition, that is the next mark. And then after getting the equilibrium concentrations, then the next mark is for the equilibrium Kc expression, and then the correct substitution in the Kc expression, and then the final mark, not forgetting the range. Now let us have a look now at the actual substitution in the table. We said the first mark is for the divide by 18, which is the molar mass. If you don't see this part, you see a 2 initial moles of steam, you'll give that 1 mark for the divide by 18. And then the second mark, remember, if the moles of carbon dioxide, change in moles of carbon dioxide you see as 0.225, it means the learner has said the moles of carbon equals the moles of carbon dioxide at equilibrium. Change in moles of carbon dioxide. So if you see this 0.225, you'll give a mark. And then after getting this 0.225, the learner will use the mole ratio. If the moles of hydrogen are twice the moles of carbon dioxide in the change, and if the moles of steam are twice the moles of carbon dioxide in the change, therefore you'll give the ratio mark. And then 2 minus or initial moles of steam minus change in moles, giving you a certain value, and then initial moles of hydrogen plus the change in moles of hydrogen give you this value, and then initial moles of carbon dioxide plus 0.225 giving you this value. All of that, that is the fourth mark. And then taking all these equilibrium moles, dividing them by 2 to get the equilibrium concentration, that's mark number 3. Remember, all of them must be divided by 2. If any is incorrect, then the learner will not get this mark. And then the correct Kc expression in the square brackets is the mark. The substitution of these values, whether they are correct or not as they were, but the learner substituted them correctly here, and squaring the hydrogen as well as the steam concentrations, then the learner will get the mark, and then the final answer must definitely be 0.00948, or the range that was given. In the concentration, the first mark is, if you see there as 1, then you know that the learner has divided by 18 as well as divided by 2. So you'll give this mark of the 1, or the learner can write it somewhere. Then you'll give the mark of 18. The second mark, remember, the learner must divide this by 2 and also divide the carbon dioxide by 2. So if you see the 1 as well as the 0.1125, you know that the learner has divided by 2 by 2, the 2 by 2, and has divided the 0.225 by 2. That is the second mark. And then in the third mark, as long as you see the 0.1125, therefore it is that mole ratio mark. The learner is saying the moles of carbon dioxide equals the mole of carbon dioxide, and divided that by 2. That is the third mark. The fourth mark, the mole ratio. If the concentration of hydrogen is twice the concentration of carbon dioxide, and the concentration of water is twice the concentration of carbon dioxide, therefore you give the ratio mark. And then the next mark, initial concentration minus change in concentration for steam, and then initial concentration plus change in concentration for hydrogen, and initial concentration plus change in concentration for carbon dioxide. All of those, that is the next mark. And then the next mark is for the correct Kc expression in square brackets, and the correct substitution of those values, and the final answer there. Most of the learners anyway do not use the concentration option. But colleagues, just ensure that you check first before you mark whether the learner has used the concentration option or the mole option, so that you can give the marks appropriately. The next question, 6.3. The graph below shows how the rates of forward and reverse reactions change with time. 6.3.1, give a reason why the rate of the forward reaction decreases between T0 and T1. It is because the steam is used up, or the amount of steam decreases, or the concentration of steam decreases, or the reactants are used up, any of those. And then 6.3.2, what change was made to the equilibrium mixture at T3? At T3, a catalyst was added, 1 mark. And then 6.3.3, at T is equal to at time T2, the temperature of the system is increased. Is the forward reaction exothermic or endothermic? Therefore, the learner needs to say the forward reaction is endothermic for you to give a mark. And then 6.3.4, refer to Le Chatelier's principle to explain the answer to question 6.3.3. And as you can see, there's negative marking. In other words, if the learner says exothermic there, the learner automatically use everything on 6.3.4, it's 0. Then if the learner says endothermic in 6.3.3, therefore you can look at the learner's answers. For the 1 mark, the learner is supposed to say an increase in temperature favors the endothermic reaction. As you see, everything is underlined there. So for that, the learner will get 1 mark. And the learner should also say the forward reaction is favored. And that is the other mark there. So these two, you can see that there are 2 different bullets. So you mark them independently. It doesn't matter which one the learner starts with. As long as you can see the forward reaction is favored, it's 1 mark. As long as you can see increase in temperature favors an endothermic reaction, it's the 2nd mark. That is question 6.3.4. Now let us move on to question 7. Two beakers, A and B, contain strong bases. Beaker A, 500 cubic centimeters of barium hydroxide of unknown concentration X. And then in beaker B, there's 400 cubic centimeters of potassium hydroxide of concentration 0.1 moles per cubic decimeters. 7.1. Define a base according to the Arrhenius theory. The correct marks there for 2 marks, the learner must say a base forms hydroxide ions, or the base forms OH minus in water, or the base form hydroxide ions in aqueous solution. So that is 2 or 0. If the learner just says a base ionizes to form hydroxide ions without saying in water or in solution, therefore the learner will get 1 out of 2. 7.2. Calculate the number of moles of hydroxide ions in beaker B for 2 marks. To calculate that, the learner uses N is equal to CV, no mark for the formula. Please do not give a mark for the formula, colleagues. And then uses the concentration of 0.1 multiplied by the concentration of 0.4. For all that, it's 1 mark. 0.1 as a concentration and 0.4 as the volume. For all of this, it's 1 mark. And the learner says number of moles of potassium hydroxide is 0.04 moles. That's 1 mark. For the learner to get the 2nd mark, the learner must definitely say the number of moles of hydroxide ions now is 0.04 moles. So if the learner just left the calculation of saying N is equal to 0.04 moles, that is for for potassium hydroxide, the learner must conclude now, because potassium hydroxide is a strong base, it means the moles of hydroxide ions will be equal to the moles of potassium hydroxide, which is 0.04 for the 2nd mark. 7.3.1. The contents of beakers A and B are added together in beaker C. The solution in beaker C has the pH of 13. Assume that the volumes are additive and that the temperature of the solutions is 25 degrees Celsius. And that explanation is just summarized in the form of a diagram. 731. Calculate the concentration X of barium hydroxide in beaker A for 8 marks. The first mark is for, the pH formula. pH is equal to negative the log of H3O plus. Or the learner can rearrange the formula saying the concentration of H3O plus is equal to 10 to power negative pH. Any one of that is the formula, 1 mark. The second mark, the substitution of 13 as the pH, and then or the substitution of 1 as pOH. And then the third mark, a calculation of a concentration of H3O plus as 1 times 10 to the power 13. That is no mark. The third, and then the third mark is the substitution of 1 times 10 to the power minus 13, which is the concentration of hydronium ions in the KW formula, and then or to calculate the pOH. And then substitute 0.1 times 0.9, which is the total volume of the bases, and then to calculate now the number of moles of hydroxide ions only. The learner will get 1 mark, and then the use of the mole ratio, which is 1 to 2, it's a mark. The substitution of the volume, which is 0.5, it's a mark. And then the final answer there, which is the concentration of barium hydroxide, is 0.05 moles per cubic decimeters. And the range there is between 0.05 and 0.06 moles per cubic decimeter, depending on how the learner has rounded off. Now, the first mark, the pH formula, it's 1 mark, whether in the form of pH minus the log of H3O plus or concentration of H3O plus equals 10 to the power minus pH, 1 mark. Substitution of 13 as a pH, it's a mark. In other words, if the learner started there, they'll give the 13 there. And then the third mark, the learner will get the concentration of hydronium ions as 1 times 10 to the power minus 13. There's no mark there. And then using KW, concentration of H3O plus multiplied by concentration of hydroxide ions equals 1 times 10 to the power minus 14. That is the formula. There's no mark. Substituting those concentration of hydronium ions correctly in that KW formula, the learner will get a mark. And then the learner will get concentration of hydroxide ions at 0.1 moles per cubic decimeter. No mark there. And then to calculate the number of moles now of hydroxide ions, it will be CV, concentration of hydroxide ions is 0.1 multiplied by the total volume of hydroxide ions, which is 0.9. Therefore, the learner will get the moles of hydroxide ions as 0.9. So this substitution of the concentration and 0.9, all of that, it's a mark. And then to get now the number of moles of hydroxide ions only in barium hydroxide, the learner will take the total moles of the hydroxide ions. In other words, the total moles of the hydroxide ions in barium hydroxide as well as the total moles of hydroxide ions in potassium hydroxide. That is 0.09 minus 0.04, which is the moles of hydroxide ions. Remember, in potassium hydroxide, that was the 0.04, because now we want only the moles of hydroxide ions in barium hydroxide. So you have to minus the ones of potassium hydroxide, the ones in potassium hydroxide, from the total moles of the hydroxide ions. So this is now the moles of hydroxide ions in barium hydroxide. Now to get the number of moles of barium hydroxide, remember we take the balanced equation. Barium hydroxide will ionize to form 2 moles of hydroxide ions, meaning the moles of barium hydroxide is half the moles of hydroxide ions. Therefore, it will be half multiplied by the 0.05 that they calculated there. Then that is the ratio mark. And then taking the moles now of barium hydroxide, dividing them by the volume of barium hydroxide. You get the mark, and then the concentration of barium hydroxide will be 0.05 moles per cubic decimeter. That is 8 marks. And then the solution in beaker C is titrated with ethanoic acid. It was found that 15 cubic centimeters of the solution neutralizes 30 cubic centimeters of the acid. The balance equation for the reaction is given there. Ethanoic acid reacting with the hydroxide ions to form the ethanoate ion plus water. 732. Is ethanoic acid a weak or a strong acid? Learners must know that ethanoic acid is definitely a weak acid. And then the reason, give a reason for the answer. There's negative marking between the reason, the answer and the reason. If the learner says strong, therefore automatically it's 0. If the learner says weak, then you can check the reason. It ionizes incompletely. It dissociates incompletely. It ionizes partially, or it ionizes slightly. Any one of those words. 1 mark for the reason. And then 733. Calculate the concentration of ethanoic acid for 4 marks. To calculate the concentration of ethanoic acid, there is positive marking from question 7.3.1. The formula, C is equal to N over V, or the titration formula, 1 mark. Substitution of 0.1 multiplied by 15, or 0.1 multiplied by 0.015. Remember, the 15 they can use in the titration formula, but if they use the formula C is equal to N over V, the volume must definitely be in cubic decimeters. And then the use of the mole ratio there, which is 1:1, and then the final answer must definitely be 0.05. Now, let us start with the titration formula. 1 mark for the titration formula. The moles of acid to the base is 1:1. That is the second mark. And then concentration of the acid multiplied by 30, which is the volume of the acid, divided by 0.1, which is the concentration of the base multiplied by 15. This 0.1 is the one that comes from 7.3.1, colleagues. And then all of that, it's 1 mark. And then the final answer there is 0.05 moles per cubic decimeter. If the learner uses N is equal to CV, formula is 1 mark. And then the concentration from 7.3.1 multiplied by the volume in cubic decimeters. All of this, it's the second mark. And the learner now uses the mole ratio there. Moles of ethanoic acid to moles of hydroxide ions is 1:1. It's a 1 mark. And then the learner takes the moles of ethanoic acid divided by the volume of ethanoic acid. There's no mark for this calculation. The final answer there is 0.05 moles per cubic decimeter. The 1 mark for the final answer, that is 4. And then question 8. A galvanic cell at standard conditions is represented by the cell notation below. X and Y are unknown electrodes. 811. Write down the name or formula of electrode X. 812. The name or formula of electrode Y. 813. The name or formula of the oxidizing agent. So the name or formula of electrode X, the name is zinc, or the formula is Zn. The name or formula of electrode Y, the name is platinum, the formula is Pt. or the name is carbon, the formula is C. And then the name or formula of the oxidizing agent. The oxidizing agent there is Fe3 plus as a formula, or Fe3 plus ions, or ion 3 ions. Any one of those, it's a mark. And then 8.2, write down one function of electrode Y. Electrode Y can be used as a conductor to complete a circuit. The words to complete a circuit are in brackets, so it is enough just to say it is used as a conductor, 1 mark. Or it provides a surface area for the reaction to take place, or anything that indicates that it provides a surface area for the reaction to take place. It's 1 mark. 8.2, write down the half reaction that takes place at electrode Y. The half reaction there, it is Fe3 plus plus an electron as reactants, and then Fe2 plus as a product with a single arrow from reactants to products. So if the learner writes products, which is Fe2 plus on the left hand side, it means the arrow must move towards Fe2 plus. Fe2 plus must be a product, and then Fe3 plus plus an electron must be reactants for 2 marks. If Fe2 plus is a product and Fe3 plus an electron, and that electron is a reactant plus but they are double arrows, you penalize 1 mark. The learner will get 1 out of 2. But if the learner swaps Fe3 plus and an electron as products and Fe2 plus as reactants, it's 0 out of 2, whether it's double arrow or single arrow. And then you ignore if the learner omits a charge on an electron, but if a learner omits a charge of Fe2 plus, in other words, writes it as Fe2 as a product and writes Fe3 as a reactant instead of Fe3 plus with an electron, then you'll penalize 1 mark. So it's Fe3 plus an electron forming Fe2. That is 1 out of 2 because the learner has omitted the plus there in Fe3 and in Fe2. And then the next question, write down the net equation for the cell reaction that takes place in the cell. For the reactants, Fe3 plus plus zinc, it's 1 mark. For the products, Fe2 plus plus Zn2 plus, it's a mark. And then for balancing with the 2, it's the 3rd mark. And then you ignore the phases, and the marking rule 6-3-10 applies. For you to be able to mark the products, there must be an arrow before them. For you to be able to mark the reactants, there must be an arrow after them. And then calculate the initial EMF of this cell. E cell is equal to E reduction minus E oxidation, and or any one of the correct formula that is given in the table. It's 1 mark. 0.77 as E reduction is a mark, minus 0.76 as E oxidation is a mark. Remember, it must be negative for 1 mark. And then the final answer there, the EMF of the cell is 1.53 volts. If the learner uses unconventional formulae, for example, E rad minus E ox or E OA minus ERA, the learner will lose the mark for the formula, but you will still mark further if the substitutions are correct. For option 2, the learner must write the half reaction of the ion as correct, Fe3 plus plus an electron forming Fe2 plus as reduction, and then writes the zinc half reaction as oxidation. In other words, Zn forming Zn2 plus plus 2 electrons. Or both these reactions written correctly is a mark. And then E naught for the iron half reaction is positive 0.77 volts. And E naught for the zinc half reaction, remember now it is written as oxidation, therefore the E naught must be positive. It must be 0.76. It's a mark. And then the addition there will give us 1.53. That's the 4th mark. And then 8.4, How will the initial EMF of the cell be affected when the concentration of the iron 3 ions is changed to 0.6 moles per cubic decimeter? Choose from increases, decreases, or remains the same. The answer there is decreases. And then question 9. The simplified diagram below represents the electrochemical cell used for the purification of copper. The impure copper contains small amounts of silver and zinc as the impurities. The diagram is given there. 9.1, define the term electrolysis. So, for the definition of electrolysis, it is the chemical process in which electrical energy is converted to chemical energy. But in this case, the underlined words are only electrical energy is converted to chemical energy. So anything that the learner writes, you just see electrical energy is converted to chemical energy, 2 marks. And then the use of electrical energy to produce chemical change, 2 marks. Decomposition of an ionic compound by means of electrical energy, 2 marks. The chemical process during which an electric current passes through a solution or an ionic liquid or molten ionic compound, 2 marks. Just take note of the underlined words, colleagues. 9.2. Write down the name or formula of 2 positive ions present in the electrolyte. So as a formula, it will be Cu2 plus and Zn2 plus. As names, it will be copper 2 ions and zinc 2 ions. Remember, it's 2 ions. Each one has a mark. So it's 1 mark for Cu2 plus, 1 mark for Zn2 plus, or as names. 9.3. Write down the half reaction that takes place at the cathode for 2 marks. Half reaction, Cu2 plus 2 electrons as reactants and Cu as products with a single arrow, 2 marks. Cu2 plus 2 electrons as reactants and Cu as a product with a double arrow, you deduct a mark for the double arrow. And then if Cu is a reactant and Cu2 plus and 2 electrons are products, it's 0 out of 2. If the charge on an electron is omitted, but these are correct as reactants and that is correct as products, it's full marks. If you omit the ion of Cu2 plus there, in other words, the learner writes Cu2 plus 2 electrons as reactants forming Cu, you deduct 1 mark. It will be 1 out of 2. 9.4. Refer to the table of standard reduction potentials and explain why the purified copper will not contain zinc. 9.4. It is because Zn2 plus is a weaker oxidizing agent for the first mark than Cu2 plus for a second mark, and therefore zinc 2 plus will not be reduced to Zn. In other words, if the learner does not start by saying zinc ions are weaker oxidizing agent, automatically the learner loses the final answer there. For example, the learner says zinc is a weaker reducing agent than the copper. Therefore, it will not be reduced to zinc. Therefore, because the first part is already wrong, therefore, the final part, even though the learner might write it correctly, the learner will not get a mark. So, here, the than copper ions, you give the mark for the than copper ions if the first part is correct. You give the mark for it will not be reduced to zinc if both the first and the second part are correct. So, you just mark it as that. In other words, the first part affects the other marks. And to give the mark of the first part, the learner must definitely say zinc ion is a weaker oxidizing agent. And the than copper, you'll only give the mark if the first part, which is zinc 2 plus, is a weaker oxidizing agent, is there. And then 9.5. Calculate the maximum mass of copper formed if 0.6 moles of electrons are transferred. We know that you can see already the moles of electrons is twice the moles of copper. Therefore, if you have 0.6 moles of electrons, it means you have the moles of copper is half that. It means it will be 0.3 moles. So the use of the mole ratio 1 to 2 is a mark. And then taking the 0.3 multiplying by the molar mass of copper. So this mark is for the multiplication by the molar mass of copper in the formula M is equal to number of moles multiplied by molar mass. That is the second mark. And then the final answer there is 19.05 grams. And then the last question. Remember, question 10 was replaced because the learners are no longer writing the fertilizer industry because it was removed. So question 10 was the addendum. Consider the table of reduction potential below. 10.1, define the term reducing agent. So the memo also is the addendum. The term reducing agent, define the term reducing agent in terms of electron transfer. So please, colleagues, in your memo, remove the part of a substance that is oxidized because that does not indicate in terms of electron transfer. If the learner says a substance that is oxidized, the learner cannot get marks. The learner must explain in terms of electron transfer. So the learner must say it is a substance that loses electrons. It's 2 or 0. And then 10.2.1, from the table of standard reduction potential, write down the strongest reducing agent. The name or formula of the strongest reducing agent. The name is chromium or the formula is Cr. Write down the oxidation half reaction with the lowest oxidation potential. The oxidation half reaction with the lowest oxidation potential, it will be 2Cl minus as reactants and then Cl2 plus 2 electrons as products. That is 2 marks. And then if 2Cl minus is a reactant and Cl2 and 2 electrons are products, but there's a double arrow, you deduct, if 2Cl minus is a reactant, but Cl2 and electrons are products, but there's a double arrow, then you'll deduct 1 mark, it's 0. It's 1 out of 2. If 2Cl minus is a product and Cl2 plus 2 electrons are reactants, then it's 0 out of 2. If the learner omits the ion, the charge on the ion, which is on the chloride, the learner just write 2Cl forming Cl2 plus 2 electrons, but the 2Cl is a reactants and the Cl2 plus 2 electrons are products, then, and with a single arrow, therefore, you'll just penalize 1 mark. And then, write down the reduction potential of the half reaction in which Cr2 plus acts as a reducing agent. That is negative 0.41 volts. The negative is important and the unit is important. 0.41 volts. 10.3. A learner pours a copper 2 sulfate solution into a zinc container. Is a zinc container suitable to store copper 2 sulfate solution? Choose between yes or no. The answer there is no for 1 mark. And then 10.3.2, explain the answer to 10.3.1 by referring to the above table for 3 marks. The learner must say zinc is a stronger reducing agent 1 mark than copper 1 mark. Therefore, the zinc will not be oxidized to zinc 2 plus. So the first mark must definitely be zinc is a stronger reducing agent. So you give the mark for the than copper if the first part is zinc is a stronger reducing agent. And then the learner can say copper is a weaker reducing agent than zinc. So you give the mark for the than zinc if the first part is copper is a weaker reducing agent. And then the reason is, therefore, zinc will not be oxidized, just like in the first option. Or if the learner does not say, the learner talks about copper ions, then learner says copper ions are stronger reducing agent, 1 mark, than zinc, the second mark. Therefore, copper ions will not be reduced. That's the third mark. So you give the mark for the than zinc if the learner says copper 2+ is a stronger oxidizing agent. Zinc 2+ is a weaker oxidizing agent than copper 2+, and therefore copper ions will not be reduced. Any of the 4 options is correct. That is all about our memo discussion, colleagues. Thank you very much for everything, and all of the best in your marking. And just ensure, colleagues, that you give the marks as required, because at this point in time, we want to make sure that the learners do not repeat the same mistakes at the end of the year. So give them the marks as required, and try by all means to put the tick where the correct answer is, or put the cross where the incorrect answer is, and go back to the learners to show them why they lost those marks. Thank you very much, colleagues, and all the best. Thank you.